Hello everyone. In the previous class, we have started with the module number 2 and we have seen some basic concepts, that is, lexical conventions, in which we have discussed white space, comments, operators, number specification, etc. So, in today's class, we start with the next lexical convention, that is, strings. So we are familiar with strings already in C programming language. So a string is a sequence of characters that are enclosed by a double quotes. So as we know how to write a string. So whenever we are writing any character, any sequence of character within a double quotation mark, so that is called as a string. String have some restriction. So that is, the restriction on a string is that it must be contained on a single line, that is without a carriage return. So if you want to write a string, so that string must be written in a single line. So string must end in that particular line only, so without any carriage return. String cannot be written in multiple lines. It has to be ended in a same line. So whenever you write any string, they are going to replace with the ASCII value, that is American Standard Code for Information Interchange. The ASCII full form is, so the strings are treated as a sequence of 1 byte ASCII value. So whenever any character when you write within a string, so that is going to be a 1 byte ASCII value. For example, a capital A, small a, etc. All these have their unique ASCII values. So the example of the string is shown here. So within a double quotation mark, there is a string called as hello verilog word. So hello verilog word is a string here. So all the characters within the string, that is HELLO space spelling of verilog space word, everything is a single, each character it is. So each character is going to be a sequence of 1 byte ASCII values. Each letter, each character is replaced with its unique ASCII value when it is compiled. One more example, A divided by B. So A by B is written within a double quotation mark. So it is also a example of string. So whatever you are going to write within a double quotation mark, so that is going to be a string. So in Verilog, if you want to use string, so you have to use double quotation mark. Within that you can write any character, so that will be called as a string. Next lexical element, identifiers and keywords. So we have come across identifiers and keywords in different programming languages. Here also Verilog HDL has its own keywords, and you can also have identifiers. So keywords are what? Keywords are nothing but they are special identifiers reserved to define the language constructs. So every language has its own keywords. So keywords cannot be used as identifiers. Keywords are strictly the special identifiers. They are going to be used as it is without any change. So they define some logic or some meaning. The meaning is available of that particular keyword. So keywords are in lower case letters. In Verilog, all the keywords must be written in a lower case letters. So identifiers are the names. So list of keywords, system tasks and compiler directives. So the keywords can be used anywhere in the Verilog HDL program, so in the system task and in the compiler directives. Identifiers are names given to the objects so that they can be referenced in the design. So identifiers, so it is a user defined name. So any user defined name or any name that is given by the programmer or designer which is suitable for that particular statement or program. So identifiers are the names given by the user or the programmer to the objects so that they can be referenced in the design. So you can use or you can create a identifiers by using any alphanumerical characters. That means you can use the characters from A to Z. It may be a capital or it may be a small. It is not a you can use any character. Along with this, you can also use underscore and dollar sign also within a for referencing the identifiers. So identifiers are made up of alphanumeric characters and the underscore and the dollar sign. Out of this, any combination you can use. Identifiers are case sensitive. That means whatever the identifier that you define or declare, the same way it is going to be used throughout that particular program. So they are case sensitive. So identifier starts with a alphanumeric character or an underscore. Remember here, identifier starts with a alphabetic character. Means you can start the identifier by the name with between A to Z, any letter. Or also you can start the identifier with the underscore. Start with the underscore. This is also allowed. But you cannot start the identifier with the digit. That means you can use the digit in between or at the last. But at the start you cannot use a digit to start the identifier. Also you cannot use the dollar sign. In between or at the last you can use the dollar sign, but you cannot start the identifier with the dollar sign. There is a reason, because this dollar sign, if you start with, it has some meaning in the Verilog HDL. There are some system tasks and compiler directives which are going to start with the dollar sign. That's why for writing the identifiers, dollar sign is not the first character. You can use this dollar sign anywhere in between. So this is how you can create the identifiers. So identifiers are the names given by the user. You can start the identifier with the any alphabetic character or underscore. You can also use digit and dollar sign, but you cannot start the identifier with digit or dollar sign. In between or at the last, anywhere you can use these characters. The examples: reg, reg. So reg is a keyword. So reg is a register, that is, it's a keyword. So all the letters are written in a small case letters. So it should be, keywords must be a small case letters only. It has some meaning in the Verilog HDL programming. So value is the identifier here. So it is given by the user. So you can, here all the letters in the identifiers are alphabetic. You can also use a digit or underscore or dollar sign. You can modify. So it is user defined name. Second example, input CLK. So input is a keyword here. and CLK. The meaning is clock. In short, they have written CLK. CLK is a identifier. Last lexical element, escaped identifiers. Escaped identifiers begin with a backslash character and end with a white space. That is space, tab or new line. So remember here, there is one more type of identifier, which is escaped identifier, in which the identifier starts with the backslash and end with a white space. The white space can be a simple space or tab or new line. So all the characters between backslash and white space are processed literally. Any printable ASCII character can be included in escaped identifiers. So this is the special thing that differentiate between the identifier and the escaped identifier. In the identifiers, there is a restriction that you can use underscore and dollar sign only, and dollar sign and digit also you can write. You cannot write at the beginning. But in the escaped identifiers, you can write anything, any printable character. It may be any special character like plus, minus, at the rate, asterisk sign, is equal to, or any printable character. And there is no restriction that you have to start with some particular letters. Any printable character can be written, but the thing is that it should start with the backslash and end with the white space. So this is escaped identifier. So here also any printable ASCII character can be included in a escaped identifiers. So again, the letters, whatever the characters that you are going to use, all are ASCII characters only. Neither the backslash or the terminating white space is considered to be part of the identifier. So whatever the backslash at the beginning and at the end white space is present in the escaped identifier is neither the backslash nor the terminating white space is considered to be part of the identifier. So example is given for the escaped identifier. Backslash a plus b minus c space. So as it is preceded with the backslash, it is a escaped identifier, and you are using plus and minus sign. These are the special characters that can be used in the escaped identifier. The same thing cannot be used in a simple identifiers. You cannot use plus or minus in identifiers, whereas in a escaped identifiers you can use any special character. One more example, backslash double asterisk sign my underscore name double asterisk sign space. So again here also, as you can see, escaped identifier starts with the backslash, and the first character used in the escaped identifier is asterisk, which is a special character. So any special character is used at the beginning also, you can use that special character. So this is escaped identifier. Next topic is data types. So in this section we are going to discuss the data types that are going to be used in Verilog HDL. So every language usually has their own data types. The first one is value set. So Verilog supports 4 different type of values and 8 strengths to model the functionality of the real hardware. So as the Verilog HDL language is for modeling the real circuits or digital circuits, in this type of language there are data types which is in which the value set we have 4 different values and 8 different strengths. The values are going to be 0, 1, x and Z, that is logic 0, logic 1, unknown value, and the high impedance. So condition in the hardware circuits for these values are, for 0 is the logic 0, or also for false condition you can use this value. For value 1, so it can be used as logic 1, or it is a true condition. X is a unknown logic value and Z is the high impedance. Also it can be used for floating the state. So value set Verilog is going to support 8 different type of strengths for modeling the real hardware circuits. So the 8 different strengths are going to be supply, strong, pull, large, weak, medium, small, and high Z. So out of this, the supply, strong, pull, weak, and high impedance, that is high Z, these are the driving. High impedance is the it is separate, it is high impedance, high Z, supply, strong, large, and weak. Supply, strong, pull, and weak, these are driving strength levels, whereas large, medium, and small, these are the storage strengths. So here strongest is the supply and the weakest is the high impedance Z. So whenever any two signals that are going to be used, so it has different strengths. So all these about those strengths. When you do a practicals, all these strengths are going to be appear in a different colors in a simulation window or in the waveform. So those are the strength levels here. So here the logic values, along with these logic values, the strength levels are oftenly used to resolve the conflicts between the drivers of a different strengths in a digital circuits. So value levels are going to be 0 and 1, and that can have these strength levels that we have discussed in the previous table. So if the two signals of unequal strengths, consider any two different signals of different strength. As we know, the strongest is the supply and the weakest is the high impedance. So like this, if we consider any two signals of the different strengths are driven on a wire, the strongest signal is going to win here. That means it's a race between the two signals. If you are applying any two values with the different strengths, one is the stronger, another one is the weaker. So out of these two, which is what is the output? The output is going to be a stronger signal. So this is first point. Then for example, if the two signals of strength strong 1 and weak 0, see here there are two signals whose strengths are different. The strength of the signal is going to be, one is strong 1 and weak 0. Now refer the table in which the strong has the higher degree or higher strength, whereas weak has a lower than the strong degree. That's why for strong 1 and weak 0, if they contend for the race in a driving signal, the result is resolved as a strong 1, because strong 1 has the higher strength compared to the weak 0. One more example. If suppose two signals of equal strengths are driven on a wire, suppose there are two signals, both the signals have the same strength, then the result is unknown here. So here nobody wins here, neither the first signal nor the second signal, because both the signals have the same strength. That's why the result is unknown. For example, if the two signals of the strength 1 and strong 1 and strong 0, so strong 1 strong 0 both have the same strength level, that is strong. So as both are same strength, the result is X. Nobody wins here or nobody lose. The result is unknown. So strength levels are particularly useful for accurate modeling of the signal contention or MOS devices or dynamic MOS, that is metal oxide semiconductor, and other low level devices. So only tri-reg. So these are the different keywords that are used later on. Here only they have mentioned tri-reg nets can have stronger strengths, large, medium and small. These are the storage strengths. So tri-reg is going to use, as reg is used for a storage purpose. There are three different type of storages: large, medium and small. Nets. The figure shows the example of the net. So what is net here? Net represent connection between hardware elements. So what is nets? Nets are going to represent the connection between the hardware elements. So consider any real circuits in which nets have value continuously driven on them by the output of the devices that they are connected to. So as you can see in the figure, net is connected to an output of a AND gate G1. So the AND symbol, whose instance name is given here G1, that is gate 1. The output is A, inputs are B and C. So net A is a net here which is connected to the output of a AND gate G1. So net will continuously assume the value computed at the output of gate G1, which is B and C. So remember here, nets are declared primarily with the keyword wire. Net is not a keyword here, but if you want to use any nets, you can declare a keyword wire, so that whatever the objects that you can use or identifier that you can use, they are going to be your wire or net. They are going to be interchangeably used. And nets are by default, they are 1 bit value. So nets are a 1 bit value by default. If you want to declare them for a multiple bit, then you can explicitly declare them as a vector that can be used for multiple bits. The term wire and net are oftenly used interchangeably. The default value of the net is Z, that is unknown value. So except for the tri-reg net, in which the default value is X. Otherwise, the default value of net is Z, that is high impedance. Nets get the output value of their drivers. So nets are going to get the output of their drivers. If a net has no driver, it gets the value Z, that is high impedance, that is by default. Example, wire A. Wire is a keyword, A is an identifier. So declare net A for the above circuit, as we have seen the AND gate circuit in which we had a output A. So that can be declared as a wire A. Then wire B comma C. Declare two wires B, C for the above circuit. Third example, wire D equal to 1 bit binary 0. So here the name of the net is D. D is a fixed to logic value 0. In the above two cases, the value is not assigned, but here the value of the wire or net D is equal to 1 bit value 0. It is done at the declaration time only. So note here that net is not a keyword here, whereas wire is a keyword, but it represents a class of data such as wire, want, or, try, try and, try or, try reg, etc. The wire declaration is used most frequently. So out of these keywords, most of the time we use wire as a keyword. So this one we have already discussed. Next one, registers. Registers represent data storage elements. So as the name suggests, registers are nothing but they are the elements which are going to be used for storing the data. Register retain its value until another value is placed onto them. So whatever the value that is assigned to the registers, it is going to retain its value until another value is assigned to that same register. So you need not to get confused between this register and that the register that is used in digital circuits, in the sequential circuits, which is triggered flip-flops. So this is not that register. So this is just a simple data storage element. So in Verilog, the term register merely means a variable that can hold a value. So this a register means it is a variable and that can hold some value which is assigned to it. So in previous topic we have seen a net. Unlike that particular net, a register does not need a driver. So without a driver, a register can hold a value. A Verilog register do not need a clock as a hardware register do. So as this is different from that hardware registers, it do not require any clock pulse. So it just a variable. If you assign a value, it is going to hold that value until it is replaced into another value. So it is just a register which holds a value. So values of register can be changed anytime in a simulation by assigning a new value to the register. So once if you are assigning any value to the register, that can be changed anytime during the simulation, in a simulation by assigning a new value to that particular register. Register data types are commonly declared by the keyword reg. So remember here, to declare a variable as a register, you need to use the keyword reg. All the three letters are small case letters. Reg is a keyword. It represents a register. So the default value of a reg data type is unknown, that is X. If you do not declare or if you do not assign any value to the register, its default value is going to be unknown value. Example of register, reg reset. So reg is a keyword and reset is a identifier. So declare a variable reset that can hold its value. So here it is just declared a value. It is not yet holding any value. Now initial is a keyword here that will be covered in the behavioral modeling. Begin. So you might have remembered in C programming, when any function start or any construct start, if it is having more than one statement, they are grouped using a brackets, curly bracket, open bracket, then write the statements, then after writing multiple statements you can close the bracket. That was used for grouping purpose. Here also in Verilog, if there are more than one statements are there, if you can group them, but by not by using the brackets. Begin and end. Begin is a keyword and end is also a keyword, and these are going to be used for grouping purpose. As in between there are two statements, if more than one statement is there, you can group them by using begin and end. This will be covered in the next module, but here just I have briefly explained this. Begin, reset equal to 1 bit binary 1 tick B1. That means it is a size is 1, it's a binary type, the value of reset is 1. Now see here, reset is a register, its value is assigned is 1 bit binary value 1. Now after 100 time units, hash 100, this is a time, 100 time units, reset value is changed from 1 to 0, that is 1 tick B0. Earlier the value of reset was 1. After some time, that is after 100 time units, its value is changed to 0. So like this register can be used. Register holds a value. Initially you have declared a register by using reg, then you have assigned a value 1 to the reset. After some time you have changed its value from 1 to 0. This is how a reg keyword and its register variable can be used. Here reset is a variable. Thank you for watching the video.